this video, we will look at simplifying expressions with exponents using power rules. There are several power rules that we use on exponents. First, let's investigate a times b cubed. A times b cubed means the product a times b is there 3 times. This means the a factor is there 3 times, and the b factor is there 3 times. What we see is the exponent of 3 was allowed to go on each factor, both the a and the b. This is called the power of a product, where we take the exponent and place it onto each factor. A to the m times b to the m. We put the exponent on each factor. It is important to note that this property only works if inside the parentheses the factors are multiplied. It does not work if we have terms that are added together. The next property we will look at is very similar. It's the power of a quotient. Here we have a over b cubed, which means we have the expression a over b appearing 3 times. This means we have 3 a's appearing in the numerator and a and b to the third appearing in the denominator. Again, you notice the same pattern where the exponent is put onto each factor, this time in both the numerator and denominator. This is the power of a quotient, taking the exponent and putting it on each factor. Again, it's important to note this only works with factors which are multiplied. It does not work if there were any adding or subtracting of terms inside those parentheses. The final power rule we will consider is when we have 2 exponents stacked on top of each other. A squared in the parentheses means we have a times a. The cubed means that product is there 3 times. Notice this gives us a total of a to the 6th, 6 a's multiplied together. We find that by taking our 2 exponents and multiplying them together. The power of a power rule says we multiply the exponents together through the parentheses. A to the m times n, multiplying the exponents. Let's take a look at some examples where we can see these power rules work out. In this first example, we see an exponent outside the parentheses. This means we're going to put that exponent onto each factor. Taking careful note that this is the power rule affects exponents. When the 3 goes on the 5, it does not mean 5 times 3. It means 5 to the 3rd power. On the a, we multiply the exponents 4 times 3 to get 12. Finally, the b also carries the exponent of 3. We can evaluate 5 to the 3rd to get 125, a to the 12th, b to the 3rd for our final answer. Let's take a look at one more example where we can see these power rules work out. In this problem, we see the exponent of 2 outside the parentheses. It will also go on to each factor in the expression, giving us 5 squared. On the m's, we multiply the exponent to get m to the 6th, 9 squared, and on the n's, we multiply the double exponent to get n to the 8th. Simply evaluating the 5 squared and the 9 squared gives us our final answer of 25 m to the 6th over 81 n to the 8th.